So on page 19, I don't want to necessarily go over problem number 1. All of that one was doing was describing how to randomly select 10 students out of the class of 32. So that one was just pretty straightforward. You just pick 2-digit numbers until you have chosen 10 students. No repeats, so you can't have repeats because you're not picking a student more than once. All right, now number 2. Let's discuss as far as digits goes, when you would use 1 digit versus 2 digits and that kind of thing. So you can see on number, okay, so the thing that tells you what size digits to use has to do with how many items there are or the percent that you're dealing with. And if your percentages go by tens, for example, 10%, 20%, 30%, and all that kind of stuff, then your digits can be 1 digits. Because you can, 1 digit represents 10% and 20% and so on. Each digit represents 10 percentage points. But if you have percentages that are, goes to the ones place, like 55%, then that has to be represented by 2 digits because you have to have 55% of the values represent one item, and then in this case 45% represent the other item. So in this case I said let each 2-digit number equals a win by a team in the World Series. And you're talking about either the strong team, which they say will win 55% of the time, or the underdog, which would be winning 45% of the time. So they're going to play the World Series, and those are the rates at which we expect them to win their individual games. So that I represent 55% for the strong team, I'm going to let the numbers 0, 1 to 55 represent a World Series game win, just a game won by the strong team. And then the values 56 to 99 and the 100th value, which is 0, 0, represent a World Series game win by the underdog team. So there's 55 numbers there. Okay, so that's one way you can do that. I think yesterday Heba had said, well, can you do like 11 out of 20? Can you just do 20 values and say 11 out of 20 is the strong and 9 out of 20 is the underdog? And yes, you could do that. But you would say ignore the rest of the 2-digit numbers. Okay, so we're going to use a random number table on the next page. I used the second one and I started at the top left corner. And now, a trial consists of a World Series. So a trial consists of picking 2-digit numbers until a team has won the 4 games in the World Series. And then you have a winner of the World Series. You can have repeats because, if 54 is representing a strong team win, you could have 54, 54, 54, okay? And it told me to complete 20 trials. So here's how that looked. If you were going to look at the numbers, here's how that might look. So this is 20 trials worth. So I'm underlining 2-digit numbers, and then I'm writing down if it's an underdog or a strong team win. So the first number, 68, is an underdog team win. 58 is an underdog team win. 30 is a strong team win. 10 is a strong team. 32 is a strong team. 67 is underdog. I still at this point haven't gotten 4 teams to win. And then 93 is the underdog. So boom, I'm done with the World Series because I have now gotten a team that has won the World Series, that won 4 games, and that was the underdog. So that's the response that I say is who won the World Series? Which team won 4 games, the underdog or the strong team? And on that one, it was the underdog. and so on. So see, this second World Series did not even have to go to 7 games. You could just say underdog, underdog, strong, underdog, strong, underdog. Oh, look, within 6 games, the underdog has won. So the underdog won the World Series. I've seen questions like this where they didn't ask what proportion of the time the underdog will win. They might say, how long will the series go on average? How many games will it have to go to? 4, 5, 6, or 7? And so I've seen that. That would change your response, by the way. Okay, but we'll not say too much about that. I don't want to get you confused. So we'll go back to the other page. And so there is a trial consists of picking those 2-digit numbers until you have a World Series winner. And then the response is the team, the strong or underdog, that wins the World Series. So this next thing, statistic, you don't have to tell me what it is. You just give me your number. The statistic was 10 out of 20 World Series were won by the underdog. So, in conclusion, according to my simulation, I expect the underdog team to win the World Series about 50% of the time. Okay, questions on that? All right. Now, on this next one, we'll go ahead and go over this third one here. The question is, how many households do you expect to have to pick until you find one that owns both a dog and a cat? And somebody has figured out or made the claim, has set forth the criteria that 20% of the households in the nation own both a cat and a dog. So I'm going to have to represent 20% in digits. So because I'm representing 20% in digits, what kind of digits do I need to use? 1-digit numbers are fine. Now you could do 2, but it's easier with 1. So let a 1-digit number represent a household. And I say let numbers 1 and 2 be a household with a cat and dog. Some other people did 0 and 1. You could use 6 and 7. You could use 9 and 0. Pick 2 digits to represent a household with a cat and dog, and the others do not have that. All right. Use a random number table. That's on the bottom of page 20 and start at the top left-hand corner. A trial consists of picking households until you get a number 1 or a 2. Its repeats are okay, and complete that many trials. So if I come over here, your trials might look like this. Look at household, it's number 4. Look at household, number 5. Look at household, number 2 has both a dog and a cat. Ding, ding, ding. I am done with that first trial. Okay, done with that first trial. And how many households did I have to look at to get one? 3. So that is my response, because I'm going to getting the average number of households you have to look at. Look here. When I went on this street, I had to go to 13 houses before I found one that had a cat or a dog. This average was wrong, by the way. It was 6. My average was 6. Did somebody use a different process and get a different number than that? What did you get? Okay, you used 9 and 0, and then what did your average come out to be? 4.5. Okay, Cameron? 5.3. Okay, is that what yours was? And it came out to 5.3 also? Cool. You got 8. What digits did you use for your 2 through 9 is not? Huh. 8 sounds a little high. In fact, what happened was I had 9.5, and then everybody kept having numbers in the 5s and the 6s today when they were, and I was like, huh, 5s and 6s, And so I recounted mine. I went back and I looked at my work and I had made a mistake, and so it really wasn't an average of 9.5. It really was an average of 6. So you might want to double check yours, but that's a matter of us saying, is that an outlier or is that because of sampling variability? And I don't know what the standard deviation is, but anyway. Okay, so what is our response, by the way? What is our response that we were measuring? Yes, so at the top of each trial, I wrote how many households I had to look at. So that's my response variable, is the number of households examined to find one with a cat and dog. So see, the response variable, this is per trial. That's what you get per trial. This is not the response variable. That's not the on average. That's just what do you put above a trial. It's then the statistic that I got was 6, and that's the average. So I expect, according to my simulation, I expect to have to examine about 6 households on average to find one with a cat and dog. Okay. So there's 2 simulations. So the key is getting things to represent your values correctly according to their percentages and making sure your trial is defined properly. So your assignment then is to do pages 21 through 23 and then the warm-up on 29 and 30. So if you look at page 21, page 21 is 4 simulations that you're going to do. Page 22 is the random number tables you will use for those. Page 23, I wanted you to look at, is an actual free response AP question. So page 23 is the actual free response AP question that they used and in which they did a simulation. And I must have been wrong. I think yesterday I said there was only one that has been done, but in fact, the warm-up that you will be doing on page 29 does ask you to do a simulation as well. The warm-up on page 29 first asks you something with a normal model, and then part B asks you to do a simulation, and then on part C or part D it gets into an extension questions about it. All right, so there's your assignment 21 through 23 and 29 and 30.